Yesterday we dealt with absolute values and equations, okay? Today we are going to change focus just a little bit, and we are on unit 1 and 2, because it's combined, point 2, and we are going to solve and graph absolute value, solve and graph absolute value inequalities. Solve and graph absolute value inequalities. So yesterday we talked about absolute values just by themselves. So can anyone remember what is the definition of absolute value? Just yell it out.
Distance from zero.
Distance from zero on what, though? On a number line, okay? So it's kind of important to realize we're talking about number lines. So yes, the absolute value is the distance from zero on the number line. So is the absolute value always going to be what kind of value? Is it positive or negative value? Positive, okay? So this is going to be the distance from zero. So absolute value is the distance from zero. So that's a pretty key thing to remember. Does anyone know what is an inequality? What does the prefix in mean? Not. So not equal. So if it's not equal, greater than or less than. Okay, so different inequalities could be less than or equal to, greater than, and greater than or equal to. Now, I know it seems very basic, but a lot of times people have a little trouble remembering which one is less than, which one is greater than. So I have a little trick to learn here. Okay, so I don't care if you think it's silly, you're all going to do this with me and just be happy about it, okay? Look at your hands. Look at the back of your hands. Okay, look at the back of your hands, please. It doesn't work if you're looking at the palms. So look at the back of your hands, okay? Does everybody know, hopefully, how to tell the difference between your left and your right hand? I'm trying to teach my 2-year-old this right now. She's not getting it yet, but we're trying. Probably because she doesn't know her letters. So your left hand, if you're looking at the back of your hands, your left hand makes an L, right? Do this. Do we all see the L? Yeah. This is an L, uppercase L, right? Okay. Your right hand just doesn't make an L. Big distinction there. Okay. Take your left hand. If you turn it a little bit sideways, the L makes a less than sign. Okay. That is the only way that some people can remember the difference. Okay. Left hand, less than. Turn it just a little bit. Your L will make a less than sign. That is what the less than looks like. Just in case you had trouble with that. I know it seems super basic, but that's how some people literally remember it. Okay, so this is a less than, this is a greater than. Get that straight first. So first thing we're going to talk about are absolute values. Absolute value less than equations, or inequalities, excuse me. Absolute value less than, okay? The general rule for these is that whatever's inside, so the stuff inside the absolute value, if it is less than a number, okay, the general rule here is that will become what I like to call a sandwich equation. Okay, and the reason I call this a sandwich equation is the stuff that is inside, you are going to sandwich it between two less thans. So put a less than on the left, put a less than on the right. This gets sandwiched in between the positive number on the right and the negative value of that number on the left. The reason that the positive is on the right and the negative is on the left is because in the number line, the negative numbers are on the left, the positive numbers are on the right. So this is what I call a sandwich equation, okay? The reason that I call this the reason you can remember this is going to be a sandwich is because a sandwich, and you don't have to write this part down, but you can if you want to. So what you are going to do is you need to remember that less than sounds like lettuce. Just go with me on this, okay? Less than sounds like lettuce. And lettuce goes in a sandwich. Okay? Less than sounds like lettuce. Lettuce goes in your sandwich. Whether or not you like lettuce in your sandwich is irrelevant here, okay? If you don't like lettuce at all, then this doesn't work for you. But that's how I remember it, okay? Less than sounds like lettuce. Lettuce goes in a sandwich equation. So, when you graph this, the graph is also a sandwich, okay? Graphing this, we're just going to be graphing them on a number line. So, write your line. You need to write a reference point of 0, so just in the middle. Write a reference point of 0. Then, you're going to put your whole number on the right. Put the negative number on the left. The sandwich equation basically becomes something called a bounded region, okay? And a bounded region is basically where everything that's colored in is in the middle, okay? So the 2 points at the end are kind of like your bread, and all the points in between are like what goes inside your sandwich, okay? This is called a bounded region graph. Bounded region. And all that means is that everything in the middle is bounded, or it's inside your endpoints. Okay? So sandwich equations, less than, sound like lettuce. Lettuce goes in a sandwich. Sandwich graph. Sandwich graph, sandwich equation. Okay? Other than that, you can also have absolute value greater than. Absolute value greater than equations. Okay, so I'm just going to give you kind of the rules, and then we're actually going to do some math here in just a minute, I promise. It's not just going to be strange theory. So, absolute value greater than. The rule for an absolute value greater than equation is that the stuff in the middle, stuff inside your absolute value bars, when it is greater than a number. Okay, this is actually going to become two separate equations. The first equation is super easy because all you do is you rewrite this, but you take off the bars. So the stuff inside greater than the number. So just rewrite this exactly the same. And all you do is drop the bars. The other equation, you're going to write an or, is you take the stuff inside, and what we're going to do here is we're going to flip the direction and change the sign. So flip the direction to be a negative or a less than, change the sign, so put a negative on it, and it is still the same number. So two different equations. So a sandwich equation, a less than becomes a less than equation becomes a sandwich just like this. A greater than equation, the way that I remember this is this is a, sorry, I'm getting ahead of myself. We are going to remember that greater can be said as great or. Like this. So I remember this as greater can be said as great or. So or goes in the middle here. Okay? You do have to write the or. So greater than equations become two separate equations. Okay? That is graphed just like this. Again, if you have your 0 in the middle, you have your negative number on the left, positive number on the right. These are what we call we kind of call them like opposite directions. Sometimes they're called hitchhiker graphs, okay? Because really these ones are moving in opposite directions. Okay, so this was a sandwich. This one actually becomes two separate equations. So that will become two separate equations. These graphs look like they're moving in opposite directions. This graph is a bounded region. So this is an opposite direction graph. Okay, so now that I've technically showed you what we're doing, now we're going to actually do it with numbers because it's going to make a lot more sense, hopefully with numbers. So we are on, I guess, example 1. It took a long time for me to get there. Okay, so again, we are going to solve and graph. We're not going to make super technical graphs today. We're just doing number line graphs. So solve and graph. Absolute value of x plus 3 is greater than 8. The absolute value of x plus 3 is greater than 8. So key thing that we need to remember here is, what does this turn into? Is this going to turn into a sandwich graph, or a sandwich equation, or is this going to turn into two separate equations? Hey. Oh, knock yourself out. Okay, so is this going to turn into a sandwich graph, or is it turning into two separate equations? Do you need the key? Well, I could have given you the key. I have a key. It's the same key as the top one. I have a key. Very small. You'll fix it so I don't have a key? Thanks. It's okay. It's fine. Okay, so, I'm sorry, what did we say? Two separate or sandwich graph? Two separate equations. So, the first one is just going to be the same thing but drop the bars with the positive. The second one, drop the bars, do not change anything that's inside, flip it, change the sign. So flip it to be negative and change the sign. Then we're just going to solve these just like any other regular equation. How would I get rid of this 3? Subtract the 3. Okay, do the same thing on both sides, subtract the 3. So we're going to get that x is greater than 5. Now, it is super important that you write the or in the middle here, and I will show you why. Or I will explain why in just a second. So that's going to be x is greater than 5. Or do the same steps here, subtract the 3. That leaves us with x plus 3 is less than negative, negative. So we add these together, keep the sign. Oops, sorry, I don't know why I wrote that. X is less than negative 11. So if I ask you to graph this, we're going to make your little number line, put a 0 in the middle. Came with a key. Oh. Super cool. Oh, I have a key. Oh, okay. I have a key. I guess I'm special. Okay, so greater than 5. So the 5 goes on the right. The negative 11 goes on the left. I really don't care if you put the little dash marks there. Okay, it doesn't matter. All I want is the reference point of 0. Hopefully you know that 5 should be closer to 0 than negative 11. If you don't know that, you can put the little dash marks, then you can count. Okay, here, the 5. Oh, one other small thing about these. When you put the circles here, should they be open or closed circles? Open circles, how do you know the difference? If it has the little, if you have to take the pencil time to write the little dot or the line underneath your inequality, you have to take the pencil time to fill it in. That's the only way I remember them, okay? So this means open circles here. The x is greater than 5. Which direction is that going? Is that moving to the left or to the right? To the right. Okay, so this is starting at 5 and everything greater than 5. Does it include 5? No, that's why it's an open circle. If it's a closed circle, it means it includes 5. So basically, this is everything just barely bigger than 5. So here, you can also, if you have difficulty remembering which direction things go, this inequality matches the end of this arrow. Okay, they're going in the same direction. This inequality matches the end of that arrow. Same thing here. X is less than negative 11. That inequality will also match the end of the arrow. So this one is going to be moving to the left or to the right? To the left. Okay? That's how we graph those. Okay, let's try another one because this, hopefully, is this like super easy so far? Is this confusing? Am I making this too easy? You don't know? That's not good. Okay. Let's try another one. For number 2, again, I want you to solve and graph. Let's solve and graph. I don't want to do too many of these. Solve and graph the following. Absolute value of 4x plus 1 is less than or equal to 5. Absolute value 4x plus 1, less than or equal to 5. So first thing you want to make sure is that your bars are all by themselves. This one, the bars are completely by themselves, so we can start. So this is going to be a sandwich equation, or are we splitting it into 2? Sandwich or split it into 2? Sandwich, because it's a less than. Less than sounds like lettuce. Lettuce goes in a sandwich. So sandwich whatever is inside the bars, sandwiched in between 2 less thans. Does the positive number go on the left or the right? The right, because that's how a number line is. So positive number on the right, negative value on the left. Now, the reason that I make these sandwich equations is technically you could make them 2 separate equations, but it's honestly a little more work than I'd like to do. If I make this a sandwich equation, there's 1 equation, there's 2 equations that I can do at the same time. So I think it's a little bit easier. That's why I like to do these this way. So what is the first step I should take to getting x by itself? Any ideas? If I was just looking at this, what's the first step you would take to getting x by itself? Subtract the 1. Do the exact same thing. Okay, so we're actually, instead of doing 1 equation, we're actually going to do 2 equations. So you're actually going to be doing both equations at the same time. So combine like terms, negative 5, negative 1 gives you negative 6. Less than or equal to 4x, less than or equal to 5 minus 1 is 4. Again, I want to do both things at the same time, so both equations at the same time. How do I get x by itself here? Divide by 4. So divide all the parts by 4, not just the middle. Okay, divide all the parts by 4. Negative 6 over 4 becomes what? Negative 3 over 2. I do not want you to change that to be negative 1.5. It's too much work, and I don't care. Okay, leave it as this is called an improper fraction when the numerator is larger than the denominator. Less than or equal to x, less than or equal to 1. When you graph this, the graphs I'm not super concerned about. I just want you to understand when they're sandwich graphs and when they're going the opposite ways. So 1 is on the right, negative 3/2 is on the left. It's a little bit farther away from 0 than 1. Are these going to be open or closed circles? Closed circle because they have the line underneath them. Excuse my line that is super not straight. And these ones, I color in everything in between. This is called a bounded region. So everything in between negative 3/2 and positive 1, any number in there that I plugged into this equation would be true. Okay? Anyone have questions so far? Yeah, you're good. Okay, hopefully this shouldn't be too bad. Let's try just a couple more. I have like 3 more, and the last 2 are kind of technicalities. So try 5 minus absolute value of x plus 4 is greater than or equal to negative 3. 5 minus the absolute value of x plus 4 is greater than or equal to negative 3. Any ideas? Where do you think we start? Subtract the 5, exactly. So start by moving the 5. You subtract the 5, that gives you negative absolute value x plus 4 is greater than or equal to negative 8. Please be careful in your handwriting that you make these absolute values not parentheses. Okay, this negative does not distribute through. That's a mistake that a lot of people will make. How is that negative actually attached to the absolute value bars? By multiplication. And what's the number that's actually there?
1.
A negative 1. Okay, so this is actually a negative 1. So negative 1 is really there. How do you assume I would get rid of that negative 1, David? If it's attached by multiplication, how do I undo multiplication? Okay, if it's attached by multiplication, how do you undo? You divide by negative 1, right? So divide both sides by -1. Does anyone remember a special kind of rule whenever you multiply or divide by a negative when we're dealing with inequalities?
You have to switch the sign.
You have to, very close. You have to flip it, okay? Make yourself a giant note. If you multiply or divide, by a negative, you have to flip the direction of the inequality. So what that means is anytime you multiply or divide by a negative, this flips. This will become less than or equal to. So it flips to be from greater than to less than. Then you just do the regular math. So absolute value x plus 4, do not drop the bars just yet, less than or equal to 8. So is this going to be, now that I'm finally to just the absolute values by itself, is this going to be a sandwich equation or split into 2? Less than sounds like lettuce. Lettuce goes in a sandwich. Sandwich equation. X plus 4. Sandwich it in between 2 less than. So less than or equal to 8. -8 on the left. Then we can solve this. How do I solve this? Subtract the 4 from all the parts. We subtract the 4. We get -12. Less than or equal to x. Less than or equal to 4. Now, I know we're almost done, so I'm going to skip the graph part unless anybody has a giant problem with that. Okay? And I have 2 more because they're kind of a little bit technical that I want to make sure you understand here. Okay, so number 4. I would like you to, again, solve and graph, even though we're probably not going to get to the graph. Solve and graph 3 minus 2, absolute value of x plus 2, is less than 13. 3 minus 2, absolute value of x plus 2, is less than 13. Where do you think I begin this problem?
Subtract 3.
Subtract the 3, right. So start by moving the 3. So subtract 3 from both sides. This leaves us with -2 multiplied by the absolute value of x plus 2 is less than 13 minus 3 is 10. This -2 is attached by what operation? By add, subtract, multiply, or divide?
Multiplication.
By multiplication. So how do I undo multiplication?
Divided by 2.
Divide by -2. Do not lose that negative. Okay. What happens when I multiply or divide by negative?
You get a negative.
So it's not really
You are going to get a negative, but you also flip the direction. So greater than
Negative.
-5. In theory, what happens when you put something, or excuse me, what happens to a number when you take it out of absolute value bars? It becomes what? Positive number, right? When would a positive be greater than a negative value?
always.
For what value of x would a positive be greater than a negative?
0.
For always, right? No matter what you put in here, no matter what you put in those bars, it's going to come out of the bars as a positive value. So it's always going to be greater than -5, right?
Mm-hmm.
Because of this is actually called all reals, okay? All reals or all real numbers. Now, you are not aware of this yet. Take off yes. All real numbers. You are not aware of this yet, but, well, a couple of you are. There are something called real numbers and imaginary numbers. You've probably never heard of imaginary numbers. You might have heard of someone having an imaginary friend, but you never heard of imaginary numbers. There are imaginary numbers in math. We don't like them, okay? But this is actually all real numbers. So there is a rule that you should write down that the absolute value of anything greater than a negative number, if you have absolute value greater than a negative number, your answer will be all real numbers.
So negative numbers are real?
Conversely, there is also a rule that tells us the absolute value of x less than a negative would be what? When can a positive ever be less than a negative? That is a no solution. You're doing odds for your homework tonight.